All right, in this video, we're going to take a look at how we can start measuring something called volume. So we've measured lengths with segments, we've measured rotation with angles, and then we measured area with two-dimensional figures, and then we also measured area along the faces of three-dimensional figures. So volume is going to be a new kind of measurement that we're going to look at. So to kind of show the motivation here, maybe the concept behind volume, I have this rectangular prism. The base is 3 by 4 and the height is 2 feet. If I was to slice this every which way along each face, so if I cut this 3-foot segment into 3 equal feet, the 4-foot one into 4 equal feet, etc., I would get something kind of like this. So if you slice each one into equally sized lengths with their respective total lengths, you're going to get these cubes here. And so if I were to count how many cubes that I'm forming that fit inside of this rectangular prism up top, the first row I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I'd have 12 cubes on this top row and then another 12 right below. So I would have 24 cubes total. Here we would say then that the volume of this prism is 24 cubic feet. So our volume we're going to measure with cubic feet, not square feet, because we're not measuring squares anymore. Now we're measuring cubes. And so that's our concept of volume. So while area measures the number of squares that can fit into a closed two-dimensional figure, volume is going to measure the number of cubes that fit into a closed three-dimensional figure. So we're going to come up with a bunch of different formulas for different solids. We've got all kinds of prisms and cones and pyramids, and our goal is to figure out what are some pretty concise formulas that are going to get us that volume there. So if I go up top here to that rectangular prism I was looking at, we counted 24 total. Now notice I could have just done 3 times 4, the area of my base, that's 12, and then multiplied by 2. Oh, that's the same number, 24 cubic feet. And so you might be tempted to say, okay, base times length times height. And for rectangular prisms, yeah, you'd be right. But remember, we have all kinds of prisms. We could have a triangular prism, a hexagonal prism. So in general, instead of just length times width times height, we're going to do area of base, dependent on what that base is, multiplied by the height of the prism. Just keep in mind that the height is always the distance between your bases there. So our formula for volume, that's going to work for prisms and cylinders, area of base times height. So we're going to say capital B for area of the base, and then H for the height. That's always the distance between our bases. Now that capital B, I cannot stress enough. That could be maybe the area of a trapezoid, or maybe the area of an equilateral triangle, or maybe the area of a rhombus, or in some weird scenarios, it could be like the area of a circular sector. So sort of like a slice of cake or something, if it's a circular cake. So don't forget all of those area formulas from chapter 11. We're still going to need them, and no, you will not get them provided to you. So make sure you remember those. That should actually give you plenty of information to get started on the 12.4 questions.